Welcome, ladies and gentlemen, to this lesson whereby we are going to have our last lesson whereby we'll focus on the relationships between current, resistance, and voltage on a normal electric circuit. With me, I'm holding a multimeter which we use as an ammeter, voltmeter for electric circuit. So this is an instrument that is called a multimeter, but I'm just holding it. I won't use it today. I want to talk theoretically about relationship between our current and resistance, and finally the voltage. So this lesson will focus on the relationship between these three things. But before I do that, I will first talk about Ohm's law. We know that Ohm's law, which we discussed in the first lesson, we stated that the total potential difference across the conductor is directly proportional to the current across the conductor at a constant temperature. I repeat, Ohm's law states that the potential difference across the conductor is directly proportional to the current across the conductor at a constant temperature. This means that whenever we conduct our experiment with electrical circuits, we must make sure that we keep our temperature constant. Fortunately enough, when we are in an environment like this, in a lab, we are going to have an environment where the temperature is not changing. But the situation where we can change the temperature in the lab is when maybe we have an air conditioner, we're changing temperatures there. That will affect our result. So keep it in mind that whenever you conduct an experiment with electrical circuits, you need to keep your temperature constant according to Ohm's law, so that the result do not get affected, because these conductors they can be affected by the temperature. Conductivity can be affected by the temperature. Okay, so today I want us to focus on the relationship between current, resistance, and the voltage. But before we do that, in the last lesson we spoke about, let's say we have an electric circuit. This electric circuit is like this. It has got an ammeter. Then it has got two resistors that are parallel. This is an electric circuit, which is ideal. So let's say we have got 3 ohms here, and here we've got 4 ohms. You see that these two resistors, they are parallel. How do we see that they are parallel? I've explained to kids that these resistors are parallel, not because they are only just alongside each other, but it's because they are in 2 different cables. You can see that these lines, they represent cables. I can say electrical wires. This is an electrical cord at home. These are wires. So everything we call it an electric circuit. As I've told you that that connection of your refrigerator at home is an electric circuit. the connection of your TV, when you plug it, it's an electric circuit. So that can be reduced into something like this. We've spoken about that. So today I want to talk about the relationship and put some more emphasis and try to put more flesh in the things that I have said before. So now, these two resistors, we say they are parallel because they are in two different cables. Look at this. We have a cable which extends like that, and it extends. Look at this cable. This cable turns here. The cable make a turn. Then there is another cable which is continuous. Meaning that these are two different cables. This cable is turning here, then this one continues and it turns here. So we say that the two, they are parallel because it's two different cables. I've got my reason for saying to you that it's two different reasons. Why am I saying that? If you understand that from the perspective of cables as I'm giving you, it will be easier for you to denote the following. Let's say we have an electric circuit which is like this, with another resistor here, then with the resistor here. You can see that we've got resistors which are parallel. Kids usually make a mistake when they are given circuits like this. This resistor, you can see that this resistor is in between them. But let us check that in which cable is this resistor connected to. We have a cable which moves in that direction, then goes down, then it makes a turn here, and it connects to this resistor. Then look at the cable. The cable continues. As the cable continues, look at where the cable will pass through. The cable will pass this first resistor, the same cable, then the very same cable pass through the second resistor. What does that mean? It means this resistor is in series with this resistor. And this resistor is parallel with this one. So it means these two resistors, they are parallel with this one resistor. But this, okay, let me give them numbers. This one is number 1, this one is number 2, this one is number 3. These are not the resistance, which is in the resistors. It's just the numbering for me to explain. Number 1 is parallel with 2 and 3. But 2 and 3, they are series. How do you know that they are connected in the same cable? So when you explain these things of series and parallel, it is best that we invite the issue of explaining the cables. How are they connected? You can see that they are connected in the same cable. So we say that they are parallel. Rather, the same wire or the same electrical cord. I'm just reducing this to our everyday life. So these lines represent the electrical cord. So this electrical cord have connected two resistors, meaning that those two resistors they are in series. But this one, number 1 resistor, it is parallel with the other resistors because they are connected into different cable and it's the same circuit, same connection. So we say that 1 and 2, 1 is parallel with 2 and 3. Then 2 and 3 they are in series together. So it is one of the things that I need to clear you from. And it's one of the things you must be cleared from. Okay. Okay. Let us continue. You saw that I was explaining parallel connection in terms of resistors being connected in the same cable or different cable. Rather, I can just still repeat that. Maybe you didn't understand. in another way. Let's say we have a resistor here. We have a resistor here. And that resistor, then we have another resistor here. Then we have another resistor here. Right? Then we have another resistor here. Just like that. Then we have another resistor. Oh, there will be many. There will be many because you are supposed to be examined on 4 maximum resistors. I wanted to write so many resistors. Then we have a voltmeter here. We have a voltmeter here. Okay? Let me explain. You see this connection coming from here and here, this connection. I want to tell you that this part where there is a voltmeter, I can say it is not the part of the circuit. It is just a voltmeter. This is not part of the circuit. We just connected a voltmeter. Rather, we're having an electrical circuit. Then we have what? We have this multimeter. We have a multimeter which we can take to voltage. We just have a multimeter whereby we did what? We went to our circuit and we connected a voltmeter. So this V, it is this D. When you see this V, it is this D. So we just connected like this. We found our circuit already there. Then we come and connected our voltmeter. So I know when we explain how current moves, some students think that current will pass through here and it moves back. No, it won't. This is a voltmeter whereby these are the connection of the voltmeter to the electric circuit, meaning that current is going to flow here. This part, it won't come to this part because this is a voltmeter. When we try to make our calculation, so we don't include this. We can't say that current is going to pass through here and the current is going to be divided and moves through here. No. But what we know from what I told you, I know that since this voltmeter is parallel to this resistor, this voltmeter is parallel to this resistor, this two, and is parallel to this one, it means that the reading on this voltmeter and the reading between these two voltmeter and this one are equal. You need to take note that these two, they are in series, meaning that both of them, they are parallel to this one alone. I can't say that the voltage that is here is equal to this one. I have to say the voltage that is here plus the voltage that is here is equal to voltage that is here. Or the voltage that is here alone is equal to the voltage that is here. But saying that the voltage that is here alone is equal to this one, it is wrong. Because this one is in series with this one. So that's what I was explaining in the previous section. Let me explain again. You can see that we have a wire or an electrical cable. Here it is moving an electrical cord, then it turns. It turns here and connects this resistor. You can see, right? Then look at the very same cable. It's not the same cable, I mean. Another cable extends. It moves straight, then it connects this resistor. Then again, the very same cable here that connected this resistor, it went through, it turned here and connected the second resistor. Meaning that one cable is carrying two resistors. One cable is carrying two resistors. So it means these two resistors, they are in series with each other, but they are parallel to this one. So it's very important for you to understand this thing of series and parallel in terms of the cables, that this cable is connecting two resistors. This one is connecting one resistor. So you can see this cable, it's one cable which have just turned here and connected two resistors. But this one is another cable. They are not in the same line. You can see that this one is not in the same line with these two, meaning that both of them, this one and this one, are parallel to this one alone. So it means these two must be added. These two must be added because they are in series. How do we know that they are in series? They are in one cable. One resistor is here, another resistor is here. So it is one cable, which is not the same cable as this one. I hope I've cleared you on that part of having parallel and series connection. So this lesson is about clearing you, making you to understand the relationship. It's about bringing some clarification. Okay, there is something that I realize that you learners, you make mistake at, and I've come with a solution. Because as a teacher, I need to teach, also give you solution to the problem that we have. We know a formula of calculating the parallel resistor, which is 1 over total parallel resistor over, which is equal to 1 over R1 plus 1 over R2, then 1 over R3, R4. Let's say we have got this electrical circuit, which have got 3 resistors which are parallel to each other. You can see that the resistors are parallel. This one has got 2 ohms, this one has got 1 ohms, this one has got 4 ohms. You can see that these resistors are parallel. So since these resistors are parallel, if we want to calculate for RP, we will use this formula whereby we will still need to make RP to be the subject of our formula. So you kids, you sometimes make mistakes by writing 1 over RP, then you substitute everything correctly. Then you think that what you got this side is equal to RP, forgetting that this side we got 1 over RP. So I came up with a solution to fix that. So from now on, this is how you're going to do it. You're going to say RP directly is equals to 1 over R1 plus 1 over R2 plus 1 over R3, R4, moving forward. You put everything in bracket, then you get the transpose of that. You say to the power -1. To avoid you having to make RP the subject of the formula, which is difficult for you. So you just put 1 over R1 plus 1 over R2, you put everything to the power -1. Then you get the correct answer by doing that. You just put to the power -1. Let us try this one. Let us compare the method and see if we get the same answer. But this one is straightforward because kids make mistakes by writing 1 over RP, then they think what is on this other side is equal to RP, yet they still need to make RP the subject of the formula. So this formula have already made the RP to become the subject of the formula. You can see that it is RP 1 over R1 plus 1 over R2 to the power -1. So this is what I came up with, and the reason I came up with this is my background of maths. I have a very good background for maths. This is what we did from another topic of mathematics in university called the fundamental of logic, whereby we're doing matrices, we're doing what we call transpose. So these are transpose, this is just a transpose. You do not need to know what it is at your level. as you grow and you learn, you go to different levels, you're going to come across this, which is very interesting. So you calculate RP straightforward. RP is equal to 1 over R1 plus R2 to the power negative 1. This has simplified everything. Let us see if this can give us the correct answer. Let's say we are calculating the parallel resistor on this circuit. We are going to say RP is equal to 1 over 2 plus 1 over 1 plus 1 over 4 all to the power minus 1. RP is equal to, let us just do it with me as you are watching. 1. Do it with me as you are watching. We're going to have 1 over 2 plus 1, because 1 over 1, it will give us 1, plus 1 over 4, all to the power negative 1, which will give us 0, 5, 7. This is a 5, let me write nice. 0, 5, 7 ohms, because it's the SI unit of resistance. So this is what we get. Let us use that method that we know, the one which I say it usually makes you to make mistake because it is long. You need to say 1 over RP, which is equals to 1 over 2 plus 1 over 1 plus 1 over 4. Whereby you will have 1 over RP. You are going to add the fractions 1 by 1. I told kids that when you add fractions, you cross multiply divided by the denominators together, but you will do that 2 by 2, meaning that you are going to have 1 multiplied by 1 plus 2 multiplied by 1 2, just a cross multiplying. Then you will have 2 multiplied by 1, which will give you a 2. So it means plus 1 over 4. I only did this one. Then 1 over RP will give you 3 over 2 plus 1 over 4. You repeat the same thing again. You're going to have 1 over RP, which is equals to 3 multiplied by 4, 12, plus 1 multiplied by 2, 2 over 8. 1 over RP, which will give you 14 over 8. Then, now we want to make RP the subject of the formula. We cross multiply. We're going to have 8 is equals to 14 RP. We divide by 14. We divide by 14. Let me finish it here. Then, since RP is now the subject of the formula, I'm going to say 8 divided by 14. 8 divided by 14. And we get 0,57 ohms. This answer and this answer, they are the same. Look, the steps, they are very long. The steps are very long. So I think I will start to discourage this. It's not wrong, I just discourage now. Discourage and I encourage. Why? Because it's straightforward. This formula is what I just thought of, and I realized that when I do it, it works. So let us do this. It's straightforward. RP is equal to 1 over R1 plus 1 over R2. You put to the power minus 1. Then you get the answer. The answers are the same. So this is straightforward. So staying up for this online lessons is good, it is helpful. At least we came up with something that can assist you. Okay, so these are one of the things that I wanted to show you so that you can know. Okay, thank you. So now, let us go to the second part. Let us go to the second part. I want to talk about series and parallel. Because sometimes you come across questions which will ask you that we have a parallel resistor, we have parallel resistance connection, and then one resistor is removed, then it is no longer parallel, it is series. Then how to solve that? So I want us to talk about that and see how it is done. I want to show you something. Let's take we've got this connection. With this connection, we've got the resistor there. Then we've got another resistor there. Then you can see that this connection is series. You can see that this connection is series. Let's take, we have got 3 ohms. Then here we've got and let me make it high, 4 ohms, and here we've got 6 ohms. You can see, right? It means the total resistance here is R tot, which is equals to R1 plus R2, R tot, which is equals to 4 plus 6. R tot is equals to 10 ohms. Okay, you can see we have 10 ohms, right? Let me take the very same resistors and I make them to be parallel and see what will happen. I want to show you the relationship between resistance in parallel and in series. Let's say I take the same resistors this time, but this time I do what? I make them to be parallel. I make them to be parallel. What will happen? It means I'm going to have RP, we use our new method. RP, which is equals to 1 over R1 plus 1 over R2. We must write the correct formula, which will give us 1 over RP. 1 over RP is equals to 1 over R1 plus 1 over R2. Please, on the formula, let us write the formula which was provided on the exam guideline. Then we write the formula which I show you as a second step, because my formula is just a workout. It's just working it out. It's simply mathematics. On the formula, let us write the formula which is provided on the exam guideline, so that if ever it has a mark, we get it. Because when you write that formula which has to be 1 negative 1, some teachers which are not very fond of it, they may mark you wrong. Yes. Okay. Then we have RP is equals to 1 over 4 plus 1 over 6 to the power minus 1. RP, what do we get? Let us see. Will the resistance increase or decrease? Remember, we use the very same resistors. We use the very same resistors. Then let us see what will happen. Look, now the total resistance RP is 2,4 ohms. You can see that when the resistors are in series, we get 10 ohms. When the resistors are parallel, we get 2 ohms. What does that mean? It means parallel connection reduces resistance. It causes resistance to be low. Whenever something that is in series and it is made parallel, what will happen to the resistance? The resistance will decrease. Then series connection increases resistance. resistance. Series connection is going to increase the resistance. So this is the first relationship. You are going to be given a question. Let's say we have this question, and you are told that we have this electric circuit with 4 ohms and 6 ohms being parallel. Then they say that if the 4 ohms resistor is removed, what will happen to the resistance? Let us remove it. If the 4 ohms resistor is removed, what will happen? You can see the 4 ohm is removed. We have 6 ohms alone in the whole circuit, and which is in series with the battery. You can see what will be the total resistance be. The total resistance at top will become 6 ohms. What happened? The resistance have increased. You understand? It means if we have a parallel connection and we remove the resistors to make that initial parallel connection to be series, then it means the resistance is going to increase, because series increases resistance, parallel decreases resistance. You understand, right? If we can have three resistors which are connected, let's say we have 2 and here this one is 4. We have 2 resistors, right? Then we calculate the parallel resistor, RP. If we are told that another resistor, the third one, is put, what will happen to resistance? Resistance will decrease even more. Since there were 2, then we added the one which is parallel. The resistance is going to decrease even more. So I know my learners sometimes, when you are told that another resistor is added in parallel, you get to think that because a resistor is added, resistance is going to increase. You need to know how the resistor is added. If the resistor is added in parallel, it means it's going to cause resistance to decrease when it is added. It is cause resistance to decrease when it is added in parallel connection. But if it is a series connection and you are told that the resistor is added in series connection, it means the resistance has increased. It won't be 6 anymore, it will become 8 ohms. So I hope you are understanding the relationship that I'm showing you now. Okay, I want to talk about the circuit that we are very fond of. The real circuit, a circuit which represents a real life situation. The circuit whereby we have the internal resistance. We have the internal resistance, just like this one. Just like this one. Yeah, we have this electrical circuit which has got internal resistance. You can see, right? I want to show you something. They usually ask me a question that if this battery has got an EMF of 20 volts, will the reading of voltage in these resistors, will the reading of voltage in these resistors be 20? The answer is no, it won't be 20, because this 20 volt is just the voltage which this battery can provide, but some of the voltage is going to be lost in the form of heat. That's why when we use batteries, you'll find that the battery becomes warm. The reason it is becoming warm is because some of the electrical energy is being converted to heat, and that causes the voltage to be lost, the electrical energy to be lost. So you need to know that, but it's something which I'm repeating. You can check the third lesson. number 3 lesson in these YouTube videos for electric circuits. I'm explaining that. So the battery is not going to have 20 volts flowing here. It is going to be less than 20 because some of the energy is going to be lost in the form of heat. So it means that we do not know how much will be recorded here, but what we are sure of is that it won't be 20. Why? Because the internal resistance is going to cause some of the energy to be lost in the form of heat. So please, on an exam question, when they ask you that, what will happen? Will we have a reading of 20? Will we have the same reading of EMF here? You need to say no. Don't just say that energy is going to be lost in the form of heat and you stop there. You need to indicate that what is it that causes energy to be lost in the form of heat, and that is the internal resistance. So you need to say that internal resistance will cause some of the energy to be lost in the form of heat. You need to give full information, a full answer, so that you can get full marks. Okay, so now as I'm saying that some energy is going to be lost because of internal resistance, it means that internal resistance causes energy to be lost. So whenever we use internal resistance, it means that energy is going to be lost. Okay. What is V-loss? There is what we call V-loss. V-loss, these are the lost voltage. The lost voltage, since it is caused by internal resistance, we say that it is given by I lowercase r. Lowercase r, which represents internal resistance. If you don't know details about it, check lesson number 3. Okay, so if we want to get how much volt is lost, we multiply total current with the internal resistance, we get the total volt that is lost. Some people, they call V lost. V lost is also called V internal resistance. It is called V internal resistance because this is the voltage that gets lost because of the internal resistance, which is equals to current multiplied by internal resistance. So this is V loss. It is easier for you to be able to denote this if you are following. Sometimes they will tell you that let's check. Let me change my electric. So let me know if you change it. They tell you that the voltage that is here in this circuit, circuit A, circuit B, circuit C, they say A record 15 volts. A records how much? 15 volts. And you can see that A is the external resistor. What does that mean? It means the voltage that is here. Since remember parallel connection, it means that the resistors have got equal voltage under parallel. If you don't know that, check lesson number 1 and 2 for this section. Parallel resistor means that the resistors that are parallel have got equal voltage, meaning that this resistor has got equal voltage with these two. Voltage of this one plus voltage of this one. Note, I never say that this voltage have got, this resistor have got equal voltage with this one alone. No, because these two, B and C, they are series. How do we see that they are series? They are connected in the same cable. It's like having a cable like this. You can see this is a cable, right? Then at a particular point, this is a cable. I'm making a demonstration of series. This is a cable. Then at this point we connect what? A resistor. Then we come and connect another resistor here. You can see we have resistor B and resistor C, right? So these two B and C, they are series. meaning that these two which are in series, they are parallel with number A, which is somewhere here. Understand? Even if there is a 10, but the cable remains the same, even if the cable is like this, it's still the same cable. It is only one cable. So you can see that here we've got one cable which passes through which passes B to C, which is connecting B to C. So the voltage that is on the 15 volt is equal to the voltage between the two, not one of them, between the two, because both of them, they are parallel with this one. So we are told that we've got 20 volt as the EMF, but A records 15 volt. It means the external part of the circuit, it is having how much? 15 volt from 20. So it means V loss is how much? How much is V loss? It means V loss is 5. How do you know? It's 20 minus 5. 20 minus 5 is, which will give us what? What am I doing? 20 minus 15, not minus 5. 20 minus 15, which will give me a 5. 20 minus 15, which will give us a 5. It means the lost volt is what? 5. Internal resistance is causing the circuit, the battery, to lose 5 volt. So it means 5 volt is going to be lost in the form of heat. So I hope you are understanding what is happening here, because I still want to show you a lot more. I still want to show you a lot more about the relationship. And now I've introduced what we call the lost volts. I've introduced the lost volts. Let me make some more emphasis on the issues of lost volts. Okay. If we have an electric circuit just like this one, an electric circuit just like this one, which has got internal resistance just like this one, doesn't matter. An electric circuit like this, they've got two types of voltage. It is going to have V external, which you know, V external. This is the voltage from the external part of the circuit, from external resistors. Here we're going to have resistor. We have a resistor which have got the voltage reading, and here we have a resistor which have got the voltage reading. I don't have to repeat that the voltage that is here plus the voltage that is here is equals to total voltage. But the voltage between voltage A and voltage B, they are not equal. They are not equal, those one, because series we say is a voltage divider. Check lesson number 1. They are not equal. Okay. So V external, this is the voltage in the external part of the circuit. Then V loss is the voltage that is lost. V loss is the voltage that is lost. I hope you are understanding. I want to do something here. You can see that the current is high here, right? You can see that the current is high. One of the things which I need to tell you, which will assist you a lot, is that the higher the current, the more the battery gets warmer or hot and lose high voltage. What does that mean? It means that when we increase the current, more current is going to affect the battery. battery to lose even more energy, more voltage. What do we mean? Remember, current is driven by the motive force. The motive force, which is the what? The voltage. So the voltage drives current. So it means if current increases, it means the voltage that is lost is going to increase, because remember the voltage is the work done per unit charge. It means that battery is going to do more work. Why is it doing more work? Because the current has increased. It means the energy to push those charges have increased, because when current increases, it means the work to push those charges have increased. So it means what will happen, this statement that I'm saying is very important for you to understand the relationship, because that's the main thing of the main aim of this lesson is for you to understand the relationship. So when current increases, it means what will happen? The voltage that will be lost is going to increase. When current increases, the voltage that is going to be lost is going to increase. Then the voltage in the external circuit, what will happen to it? It is going to decrease. So now, having said this statement that the higher the current, the more the battery gets warmer or hot and lose high energy. And there is a loss of high energy. Well, let me remember, and there is loss of high voltage. A high voltage is going to be lost when the current increases. Okay, I know you may be confused, because Ohm's law is the one which confuses you. Because the first section of grade 11, we are going to talk about Ohm's law in grade 11. But when we introduce this formula, which is saying EMF is equals to current multiplied by external resistance multiplied by internal resistance, this formula says something which is contrary to Ohm's law. Not really contrary, but contrary is because when we talk about a real circuit connection, we're going to have two types of voltage: external voltage and loss voltage. So Ohm's law is just going to talk about voltage, and when it talks about voltage, you get confused that is it external voltage or the loss voltage. But that's what I'm trying to correct. Let me make you understand what I've just explained here. What I was just explaining, what I've just explained. Okay. You forgive me with my voice, I have flu. But I have to do this because I must ensure that you also pass. Because a teacher becomes happy when his or her learners become successful. Okay. Okay. Let me sum up everything that I gave you. Let's take we have an electric circuit. We have an electric circuit like this. Then that electric circuit, it have got parallel connected resistors. This one is 4 ohms, this one is 7 ohms. You can see that the resistance is 4 ohms and 7 ohms. Right? It have got internal resistance. It have got internal resistance. Can you see that we have got internal resistance there? Okay, then we put a voltmeter. We put a voltmeter we know that this voltmeter reading will be equal to the voltmeter reading that is here. And obviously this voltmeter, it is reading the voltage that is here. But we know from theory that parallel resistors have got equal voltage, parallel resistors. So do not be surprised when you see a voltmeter. We have an electric circuit without this voltmeter, which is like this. Then what did we do? We took this multimeter, we took it to voltage. Then what do? We connected here. Understand? So this V is represented by the screen of this thing. So we're going to have a reading. So it's nothing much. So we know that the reading that is here from this V, which is represented by this thing, exactly like this reading of V will be equal to the reading of the voltage that is here. If we can take another voltmeter and we put it here, they will be equal because parallel resistors have equal voltage. You can see, right? So now you can see that these two, they are in what? They are in series. They are in series. So the resistance here, is it high or low? We can't say it's high or low. Why we are not comparing with anything, right? So then the question, we are given a question that the 4 ohm resistor is removed. 4 ohm resistor is removed. What will happen when 4 ohms resistor is removed? Let us find the resistance here so that I don't make a conclusion that you don't understand. If we want to calculate RP, then we're going to have 1/4 plus 1/7. Do not be surprised by writing this one RP. I'll write to the power minus 1 here. I didn't change anything, I just came up with this formula which makes everything easy. But you start by writing the formula on your formula sheet, then you write this one and you substitute to get the answer. You just go to the power minus 1. Don't make mistakes of writing RP and you don't put to the power minus 1 because you get the wrong answer. This was avoiding the mistakes that you make whereby you write RP and you write like this to that formula that we know and you make mistakes. So this was the solution to that. Let us find out what is the total resistance in that circuit. We're going to add 1/7. 1/7 plus 1/4 to the power minus 1. Then we get RP is equal to 2,55 ohms. So this resistance, this circuit has got the resistance of 2,55 ohms. It has got 2,55 ohms. Then we are told that the 4 ohms is removed. We are told that the 4 ohms is removed. Then what will happen when the 4 ohms is removed? Let us remove it. Let us remove it. When we remove the 4 ohms resistor, do you see the total resistance that we have? The R thought, it will become 7 ohms. It means that the resistance increase. It means that the resistance increase. And when resistance increase, what will happen to current according to Ohm's law? It means that current will decrease. Current will do what? Will decrease. When resistance increase, current decrease, because resistance is inversely proportional to current. Let me write that. Resistance is inversely proportional proportional to current. So because we increase current, did you see how we increase current? We'll increase current by removing one resistor which was parallel to 7. As I told you that parallel connection always reduces resistance. Series increase resistance, as I showed you, because you can see the total resistance is going to be 7. At first, RP was what? 2.55. So it means 7, between 7 and 2.55, which one is larger? Which is 7. So it means now in this series connection, resistance increase. When resistance increase, current is going to decrease. So what will happen to current? I related to you current and velocity. Remember, I said that when current is high, the battery will become more warmer. When it gets more warmer, it will lose more energy. What does it mean when current is low? When current is low, the battery will become less warmer, and it means it will lose less energy. And that has something to do with V-loss and V external. So since current is decreased, what will happen to V-loss? It means lost volts will decrease. Lost volts will what? The voltage that is going to be lost is going to decrease. We're not going to have much of the voltage becoming lost. The lost volts are going to decrease. Then, what will happen to the V external? What will happen to the external voltage? The external voltage is going to increase. It's going to increase. Why are we saying that the external voltage is going to increase and the lost voltage is going to decrease? This is the reason. Let's say the EMF was 15. The EMF is 15, right? Then, for example, V lost is equals to 5. It means the external voltage was going to have how much? 10. It was going to become 15 minus 5, which will give us 10. Then, the current, what will happen to the current? Then current increase. When current increase, resistance decrease. Then, let us check what will happen. Current was high in the first one because it was parallel. Now current is what? Decreased because the resistance is high. Resistance is 7 now. So it means that the lost volt. Let's take it when current was high, we lost 5. Then when current is now low, we get to lose 2. I'm giving you an example. It means 3 is going to go back to the 10. This is lost. It means here we have the 10V external, right? This time when we have decreased the current by increasing resistance, we lose 2. It means we'll remain with 3 from this 5. So it means here we're going to have what? 10 plus 3, which will give us 13. You see? The V external now, it has increased. That's what I'm saying. V external increase. Then V loss decrease. We're not going to lose a lot. We're not going to lose a lot more. We're going to lose less. So when we lose less, what does that mean? It means that when we lose less, we're going to have more on the system. And the system is our external circuit. So if we lost less than before, it means now we're going to have what? We're going to have more in the system because we lost less. I hope you understand the relationship. Rather, there was a lot of rhyming. I said a lot of words which are similar. So maybe somewhere you might have lose it. So I want to further explain the same thing to you again. Maybe you'll understand this time, because I use a lot of lines there. I was repeating some words which sounded the same. Okay. Ladies and gentlemen, let's say we have these resistors which are parallel. Two resistors which are parallel. And the EMF here, the EMF is 20. Oh, let me use the same number. The EMF is 50, right? What is happening to these resistors? Let's say this one is 4, this one is 7 ohms. 4 and 7 ohms. It means the total resistance RP is going to be 1 over 4 plus 1 over 7 to the power minus 1. Don't remember to write to the power minus 1. And don't write the formula for this one. Write the formula that you know. Write 1 over RP is equal to 1 over R1 plus 1 over R2. Then you punch this like this on the calculator. Because this is a workout. It's a step. It's simple mathematics. It's not physics. Then our answer becomes 2,55 ohms. 2,55 ohms. What is happening to this resistance? The resistance is a bit low when we compare it to what I will do next, because I'm repeating the same thing. Look at this resistance. So let's say I'm telling you that V loss, remember V loss, we also call it VIR. V loss is 5 volts. So it means that since the EMF is the total that the battery can provide, it means that we're going to lose how much? 5. So it means the external voltage is going to have 10 volts. 10 volts. You need to notice that since the resistance is low in this series connection, it means current is high. When current is high current, as we increase the current, it causes the battery to do what? It causes the battery to lose more energy in the form of heat because of internal resistance. When current increases, it causes the battery to do more work. When current is high, it causes the battery to do more work. And when it does more work, it becomes more warmer. And when it becomes more warmer, it loses more energy. It is like when you are running. When you run slow, you do less work because you are moving slow. You know, in physics, work is where a force is applied to cause an object to move. You are applying a force, you are moving up and down. Then, when you start to run more faster, it means you'll be doing more work. The same applies when current is high and running more faster. It means that the battery is going to do more work. And when it does more work, it is going to do what? It is going to lose more energy. When it loses more energy, it means V external voltage is 10 because 5 is lost. External voltage is 10 volts. You understand? Resistance is low. Resistance is low. Current is high. Current is high. Because current is high because resistance is low. Current is high because resistance is low, right? And when that happens, because the resistance is low, current is high, it means lost volt is high. Lost volt is high. External voltage become low. Why is it becoming low? Because we're losing a lot. So it means we'll remain with less. We're losing a lot. We'll remain with less. You understand what is going to happen? Okay. So this is the situation. Let's see. They say that one resistor is removed. We remove which resistor? The 4 ohms. You see, we had the parallel. And when we had the parallel, we had the resistance of 2.55. Then we remove one resistor. You see? Now, total resistance, not total resistance, because resistor is an object. Resistance is not an object, something that you cannot touch. Okay, a resistor you can touch. So total resistance is 7 ohms, because we only have one resistor there, which is in series with the wall circuit. So we've got 7 ohms. What did we do to the resistance? We had parallel and we had 2.55 when we calculate RP. Now we're just going to calculate, we don't even calculate, we just add them. Because series, we just add. So because there is only one resistor, nothing to add, we write it as it is. So it means we've got 7 ohms. Understand? So what happens to current since the resistance increased? It means current decreased. Current decreased because resistance is high. Because the resistance is high. So current decreased because resistance is high. Then what else will happen? So when resistance becomes high, it means what? Current is going to do what? To decrease. When current decreases, it means this time the battery is no longer doing more work. The battery is no longer doing more work. So since the battery is no longer doing more work, what will happen since the battery is no longer doing more work? It means V lost. The lost volt, since the battery is no longer doing more work, the battery is not going to lose more energy. The lost volt decrease. The lost volt decrease. Then what will remain with the voltage in the whole external circuit is going to increase. It is going to increase. So yeah, this is the main relationship that I wanted to teach you. I hope now you understand this relationship. This is examinable. It is rare to find an exam without asking these relationships between current, resistance, and voltage. So please go and revise these things. Don't forget to support this channel. The concept of this channel is to teach physics from a classroom background. It is different when I teach alone, not on a classroom, than when I'm teaching people. It is different. So these videos, their concept is to teach and share with you videos that are occurring in a real classroom. It's either in my extra classes or in my normal classes. That's what the concept of these videos are all about. So please support this channel by subscribing, sharing these videos with someone so that this channel can grow and support you and teach you from the classroom perspective and background. So it is very important for you to subscribe and support this channel so that we keep on showing you video. Not only do we teach physics, we also teach sociology, history of education, philosophy of education for University of Rwanda. So please support us. Thank you.